Watch their paws. Just for a moment, they've been still for the last 10 minutes. Breathing slow, completely gone. And then, something shifts. The paws start moving, small urgent twitches like they're running somewhere you can't see. The nose flickers. A soft sound escapes, somewhere between a whimper and a bark, like it almost made it out, but not quite. And then stillness again. Most people smile when they see it. They say something like, "Oh, they must be chasing a squirrel," and go back to whatever they were doing. But behavioral neuroscientists have been asking a different question entirely, not what the dog is chasing, but whether there is a they in there at all to do the chasing, whether the experience happening behind those closed eyes is anything like what the word dream actually means. And the answer, built over 40 years of sleep research, brain imaging, and some of the strangest experiments ever run on an animal, is far more unsettling and far more beautiful than anyone expected. Let's start with what's actually happening inside the brain, because this is where the story gets strange immediately. In the 1950s, researchers discovered that human sleep isn't one continuous state. It cycles, and one phase of that cycle, REM sleep, rapid eye movement, is where dreaming happens. The brain during REM looks almost indistinguishable from a waking brain on an EEG scan. Neurons firing, electrical patterns surging, the visual cortex active, the emotional processing centers running at full capacity. The only difference is that the motor cortex is chemically suppressed, a built-in paralysis that stops you from acting out whatever your brain is generating. In 1977, researchers at the University of Lyon asked a simple question. What happens if you remove that suppression in cats? The results were immediately, viscerally clear. Cats in REM sleep, with the brainstem area responsible for motor inhibition surgically disabled, stood up. They stalked, they pounced, they performed complete, coordinated hunting sequences on targets that weren't there. They hissed at things that didn't exist. They groomed themselves mid-sleep. They showed fear responses to invisible threats. The cats were, by any functional measure, living something. Something with narrative coherence, emotional content, and behavioral specificity. Something that looked, from the outside, almost exactly like their waking life, except the world it was responding to existed only inside them. Researchers didn't need to debate whether cats dream after that. They needed to figure out what kind of things cats dream about. Dogs show the same REM architecture, the same electrical signature, and the same occasional failures of that suppression, which is exactly what you're watching when the paws start moving. But here's the question that took decades to answer properly. What is actually being replayed in there? Matthew Wilson at MIT spent years studying memory consolidation during sleep in rats. His lab placed electrodes in the hippocampus, the region most associated with memory formation, and recorded which neurons fired as rats ran a maze. Specific neurons for specific locations, a neural map of the experience building in real time. Then the rats slept. And Wilson's team watched the same neurons fire again, in the same sequence, at the same relative timing, during REM. The rats were with high neurological precision replaying the maze, not generating random noise, not processing abstract information, replaying a specific lived experience, scene by scene, with the emotional charge intact. The hippocampus in dogs is structurally and functionally near identical to the one in rats and humans. The memory consolidation process works the same way, which means when your dog's paws move in their sleep, the current best understanding of sleep neuroscience says this: they are most likely replaying something that actually happened. Something specific, something that meant something to them. Now here is the part that should stop you for a moment. Stanley Coren, a psychologist and dog cognition researcher at the University of British Columbia, analyzed the relationship between dog size and dreaming behavior, specifically the frequency and length of REM cycles. Small dogs dream more often. A toy breed will enter a REM cycle roughly every 10 minutes, and the cycles are brief. A large dog, a Labrador, a German Shepherd, will enter REM less frequently but stay in it longer. Up to 45 minutes of continuous REM in a single cycle. And puppies dream significantly more than adult dogs, dramatically more. Because the hippocampus, that memory consolidation engine, is doing the most intensive work of its entire life during early development. Every new smell, every new face, every new sound, every new texture, all of it being sorted, filed, reinforced, pruned. A puppy twitching in its sleep isn't being random. It is processing the world at a rate that will never happen again in its life. But here's what Coren's size finding actually implies, and this rarely gets discussed. If large dogs have longer, deeper REM cycles, the experiences being replayed are more elaborated, more narratively extended. A small dog might be replaying a single moment. A large dog might be moving through something closer to a sequence of events, something with a beginning and a continuation. There's a layer underneath all of this that almost nobody talks about, and it changes the picture considerably. Your dog doesn't just replay what happened. The research on REM memory consolidation consistently shows that emotional weight determines what gets consolidated most strongly. Experiences that produce the highest arousal, the most fear, the most excitement, the most attachment, are the ones the hippocampus prioritizes. A 2019 study out of Budapest from the same Eötvös Loránd University group that has produced so much of the landmark research on dog cognition trained dogs on a task and then split them into two groups before a nap. One group rested with their owner nearby. One group rested alone. After the nap, dogs who had slept near their owner showed significantly better retention of the task. Not just slightly better, measurably, consistently better. The presence of the owner during sleep didn't just provide comfort, it changed what the sleeping brain did with the experience. The attachment signal, the neurological safety cue of having their person nearby, appears to modulate how efficiently memory consolidation runs during REM. What this means is something almost too simple to say out loud. Your dog doesn't just sleep better near you, they may actually learn better near you. The bond isn't just emotional. It is, in a measurable sense, cognitive infrastructure. Now, the question most people eventually ask, and the one that feels almost too personal to answer scientifically, does your dog dream about you? In 2016, neuroscientist at Harvard Professor Deirdre Barrett gave an interview in which she addressed this directly. Her position, based on the accumulated research on REM consolidation and mammalian attachment systems, was this: dogs most likely dream about their owners, not as one element among many, but as a primary recurring figure in their dream content, the most emotionally significant presence in their daily experience, the one whose absence produces the strongest arousal signal, the one the hippocampus has the most motivation to consolidate and reinforce. She was careful to frame this as an inference, not a confirmed finding. Direct imaging of dream content in dogs doesn't yet exist in the way it's beginning to in humans. But consider what we do know. Gregory Burns's fMRI research at Emory University found that the caudate nucleus, the region most associated with reward and positive anticipation, activates more strongly to the scent of a familiar owner than to any other stimulus. More than food, more than other dogs. More than any environmental signal the researchers tested, you are the single highest value input your dog's brain processes. Every day, without exception. And the hippocampus consolidates what the brain values most. The inference isn't romantic speculation. It's the logical conclusion of two separate bodies of research pointing in the same direction. There's one thing left to say, and it has a practical edge to it. Sleep quality in dogs is not static. It degrades. And the signs are subtle enough that most owners miss them entirely until something more obvious appears. Disrupted sleep, frequent waking, failure to enter deep REM, restlessness through the night, is one of the earliest behavioral markers of pain in dogs, earlier than limping, earlier than reduced appetite, earlier than any of the signs most owners know to look for: a dog that used to sleep deeply and now seems to wake repeatedly, or one that used to twitch and whimper in their sleep and has gone suddenly completely still. Both of those changes carry information. The first may indicate physical discomfort interrupting the sleep cycle. The second, in older dogs, can be an early sign of canine cognitive dysfunction, in which the neural architecture that generates REM content begins to deteriorate. Roughly 35% of dogs over 8 years old show some degree of cognitive decline. Disrupted dreaming, measurable as reduced REM muscle activity during sleep, is one of the first things to change. If the paws stop moving, pay attention. It doesn't always mean something is wrong, but it's worth knowing that it can. So the next time you watch your dog's legs moving in their sleep, that soft, urgent twitching, the almost bark that doesn't quite make it out, here's what's actually happening. A brain that runs on the same sleep architecture as yours is consolidating the most emotionally significant moments of its day, replaying them with neurological precision, prioritizing the experiences that carry the highest charge. And according to the best current understanding of how mammalian memory and attachment systems interact, The figure most likely to appear in what it's generating is you. Not because that's a comforting thing to believe, because you are the highest value signal in that brain. Because your scent activates its reward system more than any other input. Because 15,000 years of coevolution built a nervous system that orients toward you so completely that even in unconsciousness, you are what it returns to. Your dog is dreaming, and the science suggests you're probably in it. If this changed how you'll watch your dog sleep tonight, subscribe and leave a comment below. What does your dog do when they dream? Do the paws move? Do they make sounds? Tell me what you see. And if you want to understand what's happening in your dog's brain when they stare at you with those eyes while you're awake, that video is already waiting for you.